Welcome back to video 5 on conic sections. In this video we're going to look at hyperbolas, and contrary to some people's assumptions, it's not pronounced hyperbolas like a disease. It's hyperbolas. The geometric definition is given this picture where you have these almost parabola shape curves opening opposite each other. The hyperbola is the set of all points in the plane that the difference of their distances from two fixed points, called the foci, is constant. Now this sounds a lot like an ellipse. The only difference now is it's a difference instead of a sum. The segment joining the two vertices is the transverse axis. The asymptotes are lines that the hyperbola approaches for large values of x and y. Now these are slant asymptotes because if you were to draw in asymptotes on this generic sketch we have here, they are diagonal, invisible lines to which this hyperbola approaches. So the hyperbola with center at the origin has a form very similar to the ellipse, but notice since it's a difference instead of a sum, your information here is almost the same, but now the fractions with the squares in the denominator have a minus sign in between them instead of a plus sign. We still have vertices. The vertices are at plus or minus a comma 0 for sideways opening hyperbolas. And we have 0 plus or minus a for vertices where the curves are opening upward and downward. The foci are still at plus or minus C0 for opening sideways, and 0 plus or minus C for these hyperbolas opening upwards and downwards. You can see where those exist here on the curve. And if you want to be able to find your asymptotic lines, you're going to look at y equals plus or minus b over a x. This is like your slope times x. You can see there's this box here. This box helps you determine where your curves bump or have a max-min. It doesn't really make sense to say max-min when they're opening sideways, but it definitely does when you're looking at the hyperbolas that open up and down. These boxes centered about the origin help you determine how to sketch your slant asymptotes. Now let's look at how to sketch a hyperbola. Number 1, sketch the center box. That's the one I was just showing you. This is the rectangle centered at the origin with the sides parallel to the axes that crosses on an axis at plus or minus a and the other at plus or minus b. And we can find that plus or minus a plus or minus b by looking at the denominator of our equation. To sketch the asymptotes, you'll need to use the lines obtained by extending the diagonals of the central box. Step 3 is to plot the vertices. The vertices are what I was kind of describing as a max or min, but remember that doesn't really make a ton of sense in this situation if they're opening sideways, if your curves are opening sideways. So these are our vertices. They are the max or min when your hyperbola is opening upward or downward, but they're also these curve edges that are bumping the central box. sketch the hyperbola as the last step, start at a vertex, and sketch a branch of the hyperbola, approaching the asymptotes. Sketch the other branches in the same way. So this is how you're going to figure these out. Now let's go ahead and try one. In example 7, we need to find the vertices, foci, and asymptotes and sketch the graph. Check your answer using the graphing calculator, which you can do. You just have to solve for y. In this case, I have 36 on the right side and 9x squared minus 4y squared on the left side. I'm going to divide both sides by 36 to get a 1 on the right, which will also allow me to reduce my fractions. 9 and 36 reduce to just x squared over 4 minus y squared, this one reduces to y squared over 9, equals 1. And now I have my two denominators. Now remember, you have to figure out which one's which. If x squared comes first, then you know your hyperbola is opening sideways. And if y squared comes first, meaning it's not the negative one, the negative term, then you have a hyperbola opening upwards and downwards. So we know that the shape of this hyperbola is going to be something like this, where the curves open left and right. And so my diagonals will look something like this, where I'll have a positive diagonal asymptote and a negative slope, and then my central box will do something like this, where it bumps this vertice on both of these curves. So now that we have the general idea, we can use A and B to figure out our next step. If A squared equals 4, then A is equal to plus or minus 2. And if B squared equals 9, then we know that B is equal to plus or minus 3. If I want to figure out the equation of the asymptotes, we can just write this as y equals plus or minus b over a x. And so I will have y equals 3 over 2, it's a plus or minus, x. These are the equations of my slant asymptotes. And now I can draw my central box because I have A and B. I know that it's opening left and right, so my A values will be along the x-axis. So I'll go ahead and draw those next. I'm going to make every 2 notches on my grid be 1 step. And B is going to be plus or minus 3, so that will be 1, 2, 3. Point here, and down 3. 1, 2, 3. I'm going to go ahead and label these as the vertices, just for a moment so you can keep track of these. And then I'm going to draw a box that encloses this portion of the graph. So there's my central box. And now I need to find the foci. The foci are going to be when I use the formula c squared equals a squared plus b squared. That means c squared will equal 4 plus 9. So I'll have c is equal to plus or minus the square root of 13. These are my foci. If I want to write them as a coordinate point, they'll be plus or minus root 13, comma 0. This number just off to the side is approximately 3.6. So I'll be at plus or minus 3.6 comma 0. This will be the point 3.6 comma 0. And then from the origin to the left, negative 3.6 comma 0 will be my other foci point, or focus point. Now I am almost done. I can connect using a dotted line. This will be my positive slant asymptote going from corner of central box to corner diagonally. And then the other one will go the other direction. It will have a negative slope. They're both going through the origin. So it's easy to just connect these dots. And then all I do is draw the hyperbola. If I were to extend these diagonals out, and sometimes maybe it's harder if it's a larger scale, but you have to remember that the hyperbola is hugging these slant asymptotes to infinities. So I hope that makes it a little more obvious what your graph is going to look like. We know that it has to approach these slant asymptotes at the extremes. We also know it has to bump the vertices. And then we know that it's going to curve back out along these slant asymptotes. So I think if you fill in all the little pieces, the actual sketch of the curves of the hyperbolas is like the easiest part. In this example, we're asked to find an equation for the hyperbola with vertices at 0 plus or minus 2 and asymptotes y equals plus or minus 1/3 x. We're going to start with the vertices because they're extremely helpful. I know that my vertices will be at 0 plus or minus a. That means a equals 2. That also tells me that my vertices will force hyperbola pieces to open upwards and downwards. This also gives me information about how to write the equation of the hyperbola and also what's going on with this asymptote set. Since I know that a equals 2 and my generic equation for asymptotes where the hyperbolas are opening upwards and downwards is plus or minus a over b times x, that tells me that y equals plus or minus 2 over b times x. Since we have a tendency to reduce our fractions when we're working with slopes of lines, I can imply from this that b equals 6. That way, when I reduce my fraction, I will get 1/3. So I'm going to count over 6 to get my center box. 6 to the right of 0 and 6 to the left of 0. I have the edges of my center box. I can draw that in, and now I can easily sketch my slant asymptotes. And I need to find an equation for this hyperbola. I'm going to just do a little bit more. I want to actually sketch it. There's my hyperbola opening upwards part. And here's my hyperbola opening downwards part. And you see how I'm forcing it to start hugging these slant asymptotes as it continues on. If we wanted to write the equation for this, we know that since it's opening upwards and downwards, our equation will have y squared as the numerator of the first term over 4 minus x squared over 36. And that's going to equal 1. The last piece we could find are the foci, which are at c squared equals a squared plus b squared. So c is equal to the square root, plus or minus, the square root of 4 plus 36. So c is equal to plus or minus the square root of 40, which is approximately 6.3. And so my foci will be at plus or minus 6.3 and 0 in the x direction. There you go. That's how you sketch these hyperbolas.